Assalamualaikum and good day everyone. Today we'll continue our chapter 5, which is 5.2 application of trees. Okay, at the end of the class, you should be able to introduce binary search tree, decision tree, and also the game trees. Alright, let's see for the binary search tree. Binary search tree in which each child of the vertex is designated as a right or left child. So in the binary search tree, the maximum number of children that it can have is 2 vertices only. So it can have 2 children only. Alright. So each child is designated as the right child or the left child. So there are no vertex that has more than 2 children. Okay, each vertex is labeled with a key. So we see in the figure 5.2.1, the key for this tree is labeled with the number. Okay, the vertex. This is, you can read for your own. This is the summary for the last point. So we have we see in the figure 5.2.1. So we see that the egg as the root of our binary search tree here. So this is the right subtree. For the right subtree, is the vertices with the key greater than the root key, and for the left subtree is vertices with key lesser than the root key. Okay, so since it labeled with the number, so we can clearly see that the left subtree have the lesser number than 8 and the right subtree have the more than 8. Alright, so let's see the example for the binary search tree. So we have the question here, binary search tree for the word mathematics, physics, geography, zoology, meteorology, geology, physiology, and the chemistry using alphabetical order. So we have the alphabetical order here. So the first word is the mathematics. So the first word is mathematics. So we use the first word as our root. So next is we see that the mathematics is the initial for the word mathematics is alphabet M. So if the word have the initial alphabet M until Z, so it's put on the right side of the graph. If the word have the initial alphabet from A to L, so the word is put on the left side of the graph. Okay, the left side of the tree. Okay, let's see. For the second word, we have the second word is the physics. So the physics is starting with the P. So P is after the alphabet M, so it put on the right side of the tree. So we have here for the physics, and for the third word is the geography. Geography is starting with the G. So the G here is before the alphabet M, so it put on the left side of the tree. So next, move to the zoology. Okay, zoology, we see that the initial alphabet is Z. So Z here is after the M, so we need to put on the right side of the M. So right side of the M, so we see that it also Z is after the alphabet P. So that means it on the right side of the P. So we put the zoology here. So for the meteorology, since the M, so we put here. So for the geology, so we put on here. For the physiology, okay, for the P, so we see that P, so we have the Z here, so P is before the Z, so we put on the left side of the zoology. Alright, So the last one is the chemistry. So the chemistry is before the G. So we have here, let's see here. Okay, chemistry. So meteorology is put on the left side of the children since it is before the P. Okay. Okay, that's all for the binary search tree. Let's see for the decision tree. A routed tree in which is internal vertex corresponding to a decision with a subtree at these vertices of its possible outcome of decision. So we need to consider all the possible outcome of the decision. Okay, let's see the possible solution of the problem corresponding to the path to the leaf of the routed tree. So the possible solution is at the leaf of the tree. Okay, let's see the example. A decision tree that order the element of the list A, B, C. So we have the element of the list A, B, C. So firstly, we just we know that we have the list of the element is A, B, C. This is just as a reference. So if you are already expert for drawing your own tree, so you do not need to write down the list at above of the your tree. Alright, so firstly let's consider for the element A and element B. So for the element A and B, what we need to consider is whether A is greater than B or the A is less than B. So if A greater than B, so our element order of element has become B, A, C. Alright, so B, A, C. So this we only consider element A and B. So the another possible outcome is we need to consider for A and C. So for A and C, we also need to see whether A is greater than C or A is less than C. We see that if A greater than C, so we get the order of the element as the B, C, A. So the next possible outcome for the next possible comparison for us is B and C. So for B and C, for the element B and C, we need to consider whether the B is greater than C or B is less than C. If B greater than C, we get the C, B, A. So there are no possible outcome or no more comparison that we need to do. So we can say the final answer as the CBA. So we need to rearrange as the A, B, C. We read from right to the left. So we have the A, B, C here. So we already know that the A greater than B and B greater than C. So we put the expression here, A greater than B and greater than C. Alright, so let's move to the next. So we see here B is less than C. So if B less than C, we get the BCA. So there are BCA. So we know that we read from right to the left. So we have the ACB. So we know that A is greater than C and C is greater than B. So we write down A greater than C and greater than B. Okay, so for A less than C here. So for A less than C here, we see that A greater than B and A greater than C, A less than C. So we get B, A, C. So there are no possible outcome, no more comparison we need to do, since we already know A greater than B and A less than C. So we just put the final answer, C greater than A greater than B. So for the A less than B, so we need to consider A, B, C. So we have another comparison which is B and C, and we get B greater than C or B less than C. So we have the order of the element here, A, C, B. So we consider for compare A and C. So we get A greater than C or A less than C. So we get the final here is the CAB. So since we need to read from right to the left, so BAC. So we know that B greater than B is less than A and A greater than C. So we get the final answer. So for A less than C, we get the ACB here. So we know that B greater than C and A less than C. So we have the B greater than C greater than A. So here we know that A less than B and B less than C. So we just put the final answer. C greater than B greater than A. So that's all for the decision tree. Alright. So this is the final answer for the decision tree. Okay, so let's move to the game tree. Okay, we use the game tree to analyze a certain type of game. Vertices represent the position can be seen as in progress. Edges represent legal movement between this position. Game tree is infinite if the game they represent never end. So let's see a game tree that represent the first two level of the tic-tac-toe game. Alright, let's see we have the tic-tac-toe game with the 9 here. So we can put X with the different place in the different place. What in this picture we only show the example we put on the 3 place. Okay, so for the second stage we get O. We put O on the different place. Okay, so if we put X here, we can for the second stage. For O, we get 1, 2, 3, 4, 5, 6, 7 possible place to put an O. So this is just an example how you to do the game tree. Alright. So this is your exercise. That's all for today. Thank you.